Hi everyone, this is mg5004, topic 2, class 2, part 2. Now I suggest you advance to slide 9. There's a little box, square box at the left hand bottom corner of your screen that should have a 31 in that. Click on that and you should be able to advance to slide 9. We need to spend some time now classifying functions. Those of you that have done the diploma paper will remember from the trigonometrical work that a lot of the functions that you're looking at, sine curves, cosine curves, etc., they repeat regularly, and we talk about them as being periodic functions. They repeat. And the same pattern is repeated every cycle. We talk about the period, and sometimes we use a t, or sometimes we use a p. And if we're going to use a t, then we can write it like this, because adding the period does nothing. In this particular one, we can see that the period is going from here to here, and then it repeats itself again. So we can figure out that the period is equal to 10 milliseconds, or 0.01 seconds. Then if we think about that in 1 second there'll be 100 cycles. And that is because 1 over 0.01 is equal to 100. Now this is where, if you remember, or you should have done it in year 12 as well, but we talk about this as being the frequency, and it's 1 over the t, 1 over the time period. Further classifications that we can make on a function are whether or not they are symmetric about the vertical axis, about the y-axis. All of these three in the diagram at the bottom of the page, all of them are symmetric. So these are all symmetric. And any function that is symmetric about the y-axis is said to be an even function. So if it's symmetric about the y-axis, then it's even. So it's an even function. And what this means is that if we take the value of the function for negative x, it's still going to be the same as if we just took x. Looking at diagram A, what would we have to add to that to produce an even function? Okay, an even function is one that's symmetric about the y-axis. So all we have to do is make it symmetric. So we need to put in the mirror image, more or less. Now we have an even function. Looking at graph B on this slide, this is very common. This is the sort of function that represents a heavy cable that's hanging under gravity, and we often talk about this as being a catenary, like that. Now have a look at it. It is symmetric about the vertical axis, so it's even. It's also continuous between the two endpoints, which I guess is what you'd need for a cable anyway. But we can look at it, we can say, yes, it's an even function because it's symmetric and it's continuous. Some functions are what we call anti-symmetric. And if it's anti-symmetric, then it's an odd function. So if it's an odd function, then we have this. We have that the f of negative x is equal to negative f of x. That's what makes it an odd function. And what we're doing is we're actually rotating about the origin 180 degrees. So this one's really easy to spot here. If you take the right-hand part and rotate it around, then you get the left-hand part. Another way of looking at these is that if it were symmetric around the y-axis, then we'd have this bit here. And then if we flip that over, and that is in actual fact what we've got, then it is anti-symmetric. Similarly here in the first one, if we reflect it like that, and then flip it over down here, and that is actually what we've got, then that is anti-symmetric. So let's have a look at an example. Let's take f of x equals 6x cubed minus 5x. What we're looking for is to see if this is an odd function or an even function. So if it is odd, then putting negative x in will end up as the opposite of putting in x. So let's put in negative x. So with x is equal to negative x, then 6 times negative x cubed minus 5 times negative x is equal to negative 6x cubed plus 5x, which if we factorize out a negative sign, which then we can see is the opposite of f of x. So then it's an odd function. If you look at the bottom graph, suppose we wanted to make that into an odd function. The easiest thing to do would be to make it symmetric and then flip that bit over the x-axis. So we're like this. And then, of course, if we rub out that bit, we've now got what we wanted. Now this is an odd function. Looking at the left-hand graph there, you can see that that is an even function. It satisfies that f of negative x equals f of x, that f of negative 2 is equal to f of 2, for example. Now, if on the other hand it's not, then we have that idea that it's an odd function. Look at the sine curve. Look at the sine curve. Is the sine curve, so that's your sine curve, is that an even function or is that an odd function? You should know that sine of negative theta is equal to negative sine theta. So that makes the sine curve an odd function. And if we look at it, it's anti-symmetric. If we were to put in the reflection around the reflection in the vertical axis, then in order to match it with the graph, we'd have to be flipping it over down to there. So it's anti-symmetric. What about the cos curve? Now the cos curve starts there. so that's cos theta, that's symmetric. And we know what we do if we thought about it, that cos theta of negative theta is equal to cos theta. That makes it an even function. And if we check it out, we know that it's symmetric, like that. The second graph on this slide is an odd function. It is antisymmetric. If we were to create the mirror image over the y-axis and then flip it, we would get the actual graph. So this is antisymmetric. And if it's antisymmetric, then it's odd. And we'll find that f of negative x is equal to negative. So it's an odd function. Check out these ones. A, have a look at it. That's symmetric about the y-axis. B, that's antisymmetric. If you were to reflect the other one over the right-hand side over the y-axis and then flip it, you can see that it's antisymmetric. Part C, there's no way that that's either, so that's neither symmetric or antisymmetric. So it's neither odd nor even. If you look at D, it's symmetric. It's symmetric about the y-axis, so it's an even function. And if you look at E, it's neither. It's neither symmetric nor antisymmetric, so it's neither odd nor even. If you look at F, it's antisymmetric. If we were to draw a reflection around the y-axis and then reflect it that way, then we've got what we need. So it's antisymmetrical. So then it's odd. In graph A, clearly it's symmetric, and in graph B, clearly it's antisymmetric. They were two of the ones on the previous slide. I mentioned before about any function whose output repeats itself regularly is called a periodic function. And that's where we've got f of x plus t, where t is the period, is what you get. So t is the period, or sometimes p is the period. And if we're talking about p, then we might want to write it like that. And that's a very common way of writing sine curves where the period is 2 pi. You might write f of theta plus n 2 pi, or 2 pi n. You often see that written. Now we know that sine and cosine repeat themselves every 2 pi, and that tan repeats itself every pi radians. So let's have a look at a curve, say sine 3 theta, and we know that that's going to repeat itself every 2 pi radians. So we could write that as sine 3 theta plus 2 pi, because we know that it's going to repeat, so it will be the same. Taking out a common factor of 3, is going to give us, look, there's the period. So the period in this case is 2 pi over 3 radians, if that's how it's graphed. So it repeats itself every 2 pi over 3 radians. Now we can say, and you probably remember, that the time period, or p, whatever you're calling it, is 2 pi over omega, where omega is this number in here, the angular frequency. So we could have gone straight to that by saying that the time period was 2 pi over 3. Now we've also already had a brief mention that the frequency is 1 over t. So if our formula is 2 pi over omega, then our formula for the frequency is going to be omega over 2 pi, or it's going to be 1, or 1 over p as well, doesn't matter, like that. And we could, if we knew p, we could, or t, we would find that omega is 2 pi over the time period, just by rearranging like that. Let's take a basic graph and let's make it do various things. What we need to do is, let's first up make it symmetric. Let's make it with a period of 1. And if it's going to be symmetric, it's going to be like this. So if we're going to make it symmetric, it's like that. And if we're going to make it symmetric, it's going to be like that. So that's -1/3, and that's -1. So now it's symmetric, and it's even. But let's look at it. How long is it taking to actually repeat? It's actually taking from there right through to there to repeat. So it's got a period of 2. If we wanted to draw it with a repeat of 1 unit, then it would have to be like this. Sort of like a sawtooth. And so that's 1, and that's 1/3. Like that. And then that's got a repeat of 1 unit. What if we wanted to create it not into a symmetric one like we did first, but what if we wanted to create it as an odd function and give it a period of 2? So now, here's our original. Now, in order for it to be odd, it's got to be anti-symmetric. So we're going to have to do the short bit here. So that would take us to -1/3. And then the longer bit up to here, which would take us to -1. And now, if we were to repeat that, the whole period is going to go from there to there. So t would equal 2, whatever the units are. And this is now anti-symmetric, and thus it's an odd function. So what we're doing is we're just categorizing functions. So there are the well-drawn versions. Categorize these ones as to whether they are odd or even. A is going to be even because it's anti-symmetric. Sorry, it's going to be odd because it is anti-symmetric. We could reflect it. And then if we flipped it up that way, then we would have what we've got, the blue line, so it's odd. Clearly, B is symmetric, so it's an even function. C is a straight line. That's neither symmetric or anti-symmetric. It's neither odd nor even. Similarly, D is neither. If you have a look at that, that is neither odd nor even. E, if we flipped and moved, yes, we'd see that was anti-symmetric. It's odd. And F is symmetric about the y-axis, so that is even. Let's play around with a slightly more complicated graph and make it periodic and give it different periods and make it even and make it odd. Okay, so the function goes from 0 up to 1, and down to 1.5 and then along. So that's our basic function. So to start off with, let's make it just periodic with a period of 2. So start off with our basic one. It went up, down and along, and that took us to 2. So we're just going to repeat that. Up, down and along. Up, down and along. And that'll give us the period there of 2 units. Now, what if we wanted to make it, periodic with a period of 4, and we want to make it even? So let's draw our basic one, and it's up, down and along. Now, if it's going to be even, it has to be symmetric around the y-axis, so we're going to have to draw it out here. To there. That's going to be at -2, and that'll be at -1.5. And if we wanted to have a period of 4, it's going to go from -2 to 2 here. Now, if it's going to be an even function, it's going to have to go along there to 2.5 this time, so 2.5, and then it's going to go up the short bit and along like that, and it'll finish at 4. So we could take its period from here as well. If we wanted to create the same thing, but this time we wanted it to be an odd function, so that's an even function. If we wanted it to be an odd function, so that's taking us to 2, then it's got to be anti-symmetric, so it would have to go along this extra 0.5 like that, and then it would have to have the short bit and then the longer bit out there. So this is 2.5 to there, and this would be to 3, and it would come up at 4 off the screen. And similarly, if we go the other way, it would go down, and it would come up, would go down to 1, and then so that's -1, it would go down to -1.5, and then it would go along to 2, -2, then it would go along, etc., and then it would be up here again. So it's got a period of 4, and it is anti-symmetric, so it's now odd. So what we've done is we've taken that original function that looked a bit like this, like that, and the first one was just plain periodic, period of 2. The second one we changed it to have a period of 4 and made it even, and the third one we made it odd and gave it a period of 4 as well. So this is the end of topic 2, class 2, part 2. So next time you're going to have to advance your slides to slide 22.